Siddharth sir, are you there?
Yeah, yes, ma'am.
Yes. Good afternoon, everyone. On behalf of Walchand Institute of Technology, Solapur, I, Mrs. Priyanka Udge, Assistant Professor at WIT Solapur, extend a warm welcome to all of you on the second day of our industry collaborated 1 week national level faculty development program on AI powered teaching excellence organized by the Department of Electronics and Telecommunication Engineering at Walchand Institute of Technology, Solapur, in collaboration with iTech Robotics and Automation Private Limited, Pune, and Technova Solutions Private Limited, Pune. Now, it's my pleasure to introduce our first guest, Mr. Siddharth Somnath, AI engineer, Technova Solutions Private Limited, Toronto, Canada. With over 3 years of industrial experience, Sir holds BTech in Computer Science and Engineering from MIT College of Railway Engineering and Research, and his area of experts include generative AI, large language models, AWS cloud, retrieval augmented generation systems, agentic AI, and AI-powered automation solutions. He also conducted multiple workshops, seminars, and technical sessions on artificial intelligence, generative AI, cloud technologies, and other emerging technologies at various universities and institutions. He also worked on several industry level agentic AI and generative AI projects. So we are honored to have him as a resource person for this faculty development program. So with the great enthusiasm, I now invite Mr. Siddharth Somnath to take over the session and share his expertise with us. Over to you, sir.
Yeah, thanks, ma'am. Hi, good afternoon, all. So yesterday's session was basically on the LLMs and tools, how we can use, and some basic info about the AI, right? So today I will be showing today the summary of this all over session till 3:30 will be NET and hands-on workflows. We are solving the real problem here. I will be triggering the workflows where you can see the execution and exactly how the AI and the workflows are solving these agents. So before that, I want to give some more context about exactly how the AI is basically now spreading, at which industries it got a more what we can say a grip, and which need to be covered. And another thing is that we are exploring some NVDI tools and NVIDIA use cases where like we in the ENTC department, like what we can say some hardwares where we can use like Jetson Nano and other products like the NVIDIA. So basically, we will be taking overview of these 2 to 3 subjects, and yeah, I will share my screen and I will start this session. Okay, my screen is visible, right? Hello.
Yes, sir. Screen is
Yeah.
visible.
Yeah, okay. Yeah. Thanks for the information. Yeah. So this is recently, what we can say, released by the Anthropic. This is a research where they have did a detailed survey about AI. How many sectors are there where theoretical and the observed AI coverage. So uh, uh, whatever we are thinking that AI will be taking the jobs and AI will do everything. So we can say how much part it is just covering in the all sectors and what part still it is not started also, right? So these are the sectors like transportation, production, install and repair, construction, agriculture. So this whatever the doc is released. So this is released by what we can say a well-known company in Anthropic and Cloud, where we are using the we are using daily in our day-to-day life cloud. So they have some what we can say subscriptions, and they will be providing subscriptions, and they did a detailed overview, a detailed survey about an AI. We can say a transportation, production, install and repair, construction, agriculture, office admin, how much percentage it is covered. So regarding the sales and personal care means like what we can say a maid, where she is coming to home and doing some other stuff work. So in the other ground maintenance works and food and servicing also. In the hotels currently, all the waiters are working here. No any physically I will be has not taken place. and the productive services also, productive services like security guards. They now currently the humans are only working. There are no physical AI, no robots are currently placed here. And another healthcare support also. Most of the hospitals are currently utilizing the humans rather than going to the agentic workflows like whatever the calls are there, any patient's calls, so whatever the appointments, checking the doctor appointments timing, and submitting the reports. So all this currently not much used by not much or utilized, and their integrations of any still, as what we can say, still it is not 100% utilized there, 100% installed there. So arts and in the arts and media now currently we can see the Gemini LLM models are creating the images in very realistic way, and creations of an video like Nanobana is a recently model they have released from the Google, where they are what we can say the output of an models, the video creation is a bit much more accurate than a real movies also. Now currently new movies that models are currently they are using, right? So in this art and media currently the AI is spreading, and education and library also bit part, some part is not covered and some part is covered. So this is all about the graph where we can see the how much AI is occupying on the behalf of on the two factors like the theoretical and the observed. So these are the industries where we can evaluate how much AI can do, at which type of level work it can do, and what exactly the problem segments they are solving. So currently we are in the era of an software AI, means non-touchable AI, right? So in the upcoming 2 to 3 years or 2 to 4 years, in India, we have certain companies also, and in the overall world, we have certain companies where they are providing the physical AI robots, where they are doing the repetitive works. They are doing the repetitive works in the manufacturing industries and in the households also. So soon we will be seeing that things also in our day-to-day life, where if we go any restaurants there, the humanoid robots are serving the dishes and solving the real-time problems and managing the whole restaurant. And like in the manufacturing industry also, there are the certain manufacturing belts are there. Like in the first phase, the chaser will be produced. In the second phase, electrical wires and other installations are done. In the third phase, engine will be installed. In the fourth phase, all the assembly parts will be done. In the fifth phase, all the testing will be done. So whatever this the manufacturing conveyor belts are there, whatever the process is there, so they are mostly now the arms has been installed. What we can say a physical AI has been installed there. So they are doing the work 24/7. We are replacing the labors also there. So there is one known company like Boston Dynamics, like that. A company is making a huge improvement in robotics and in the physical AI. Now, currently, they have released certain videos, also certain letters, certain what we can say, a certain newses, a list of newses where the robots can flip, robot can do everything. They can lift the heavy weights, they can install in the racks. So whatever the librarian can do, he can tell that there is a book, there is a rack. So all the information we can do, and all that robots can do basically. So this is all about a theoretical capability and the observed usage by the occupational category. So this is the whole graph where we can see how much AI is occupied in which area. So now currently this will be filled in upcoming years. So this will be totally filled by the physical AI and the software AI. So yeah, this is all about the overview. And coming to the NVIDIA, where NVIDIA is providing a certain services, right? So I'm not a sponsor of an NVIDIA, but I use this console most than AWS, most of an AWS, right? So here we can see robotics and edge, high performance computing, autonomous vehicles, quantum computing, and quantum computing. AWS also providing a very good services. Basically, now uh, the server's capacity, the compute capacity is way much higher than in the previous years. So we don't need to install everything at our place. Just we can rent an hourly, where we need to give the compute, we need to give the money as per the compute we are using. So this works about the computing and design and simulations also. And here there are the certain things where uh, what we can say in the robotics and edge. So there are the certain NVIDIA released packages where we can see uh, simulations we can create, like rather than directly building the physical things. First we can see the simulations in the software. If I have I don't have much about ENTC knowledge, but I'm trying to explain the things to you. So what exactly the NVIDIA is providing is that you get a simulation world where you can check how that AI agent or that prototype works, and how it behaves, what will be the input and what will be the output. And rather than damaging the physical structure after creating and testing, you go with the software first, you try, you simulate all the things. If all it is working fine, then only we can then the whatever the prototype is there, the MVP is there, then only it is been created. So we can explore more in more another sessions about NVIDIA and how much services they are giving and what exactly the new things are coming up. Because NVIDIA is a company now currently, it is doing a more improvement in the physical AI and in the in the computing in the computing also. See, running an LLMs, running an AI need a huge compute, and it needs a huge what we can say CPUs and GPUs. And architecture level, NVIDIA is providing a hardware, a platform, a hardware, a support where AI can easily run and it can perform very well, where we can get a good outputs. So there are the certain recently NVIDIA hasn't released like Blackwell. So Blackwell is a servers. Blackwells are the servers, or racks of and servers where Microsoft, Google, and other big companies, big giants companies are taking the servers from the NVIDIA. They are training their AI on that servers, where the cost, the electricity, the cooling problems, all the companies are solving. So that's why many companies are investing in this. So we can go through in another sessions in detail
So we
whatever the
like
Jetson
in
Nano
order
is there,
to finalize. Okay.
Jetson models and Jetson software. So there are different types of services. So this was the overview. Now we are coming to the main problem. So what exactly I have made is to the faculties most of the thing, where yesterday I was talking about the N10. I have shared you one image also, where how we can create the workflows and how exactly the problem is solved. So I have took one problem statement. Today I won't be sharing any PPT or just I'm talking. I will be showing you a detailed execution, how exactly AI solves and problems, and it is totally what we can say integrated and created a workflows by me. Another thing is that it is very easy. It is not more in a technical way. You can also create workflows as per your problem segment. So what exactly the problem is that what yesterday I have sat and evaluated some points where I especially interested to solve about these two problems. First one is that faculty members want to stay updated with the latest research papers. Like most of the people here are pursuing the PhD or wanted to pursue PhD, and most of the faculties read the research papers. Right. So rather than going every website, rather than searching the research papers at every website, what here the time where goes is that reading many research papers every week takes a lot of time, right? And the important thing is that reading a paper takes a more time, and finding the conclusions, gathering the number of and types of research papers, and creating a conclusion where suppose like we need to research on any topic, then we go through the different resources. It is very time consuming and headache also, where if you have a less time, then the whatever the accuracy is there, that will be decreased. So this problem we are solving. And what exactly the workflow does is that first, it is a one click button When you click that button, workflow starts, workflow goes to that website, that node goes to that website. It will search a related, what we can say, a research papers, that topic research papers. It will gather number of and research papers. It will extract all the data from it. After extracting all the data from it, it will rank that research paper, which research paper is good, which we need to be, what we can say, which we need to be read, or which is not useful for us. So after that, whatever the whole summary is there, after getting the summary, the N10 workflow will send a email to you with link, with a description, with a list of an research paper that I have made a conclusion and this is your result. So this mail you will be triggered. So here we will check a one by one. Step one, when we start an a workflow, it will automatically, when click a button, the workflow will be started. And whatever the research interest we have been we have gave a input, like AI in education, LLMs, renewable energy, smart grids. It may be any topic, depending upon it. It may be like I want a research paper on the VSLI. I want a research paper on the, what we can say, a quantum computing. I want a research papers on this topic. So you can specify any topic to it. I will show every configuration. I will show where we need to make an edits, where how much easy to make an edit. It is. I will be not showing any code to you. I will be showing a UI, where you can drag and drop the nodes. You can adjust the nodes as you want, and you can add a node. You can delete that node, and you can add a number of resources to that node. And third one is that collect the latest research papers, like, like Arxiv is an one platform where, here this platform provides a number of research papers, and in this way, we can have a different websites. We can have like number of 10, 12, 15 websites where we need to add in that workflows, and we need to integrate that nodes. So I have took for example for the two, for the current, and after collecting that website, AI reads and summarizes. Uh, Sorry, which link you need, sir? Okay. Yeah, AI reads and summarizes it. AI reads and summarizes it. A short summary, a short summary, a short summary, a relevant score, why it is important in that research area. So this all evaluation done by a small LLM, where we can add an API, or we can give our localhost, where we can run an LLM on a systems. So after that, select the best papers. So AI will evaluate. It will self evaluate. Papers are ranked on based on the relevance. Less relevant papers are automatically removed from that list. So we won't be getting any unnecessary content. So we want a output in very precise way. Then it will create a research digest, where paper title, summary, research link, a relevant score, and it will send a faculty. It will send an email to faculty. Now we will see that workflow. So yeah, so this is an N10 platform where you can drag and drop, you can create a workflows in this way. It is not a rocket science. It is very easy. I will show you everything in very simple way, right? So first thing is that, this node, whatever this node, this is a starting node. Whenever you click to execute workflow, it will start your workflows, right? So here, this is a node where you can add here from here only. There are the certain nodes here, where you can directly search that, run immediately node, which is execution node also it is called. You can directly add this node at the first, and after that you can see a arrow is there. We can drag and drop this. These are not fixed one. However you want to design, you can design these workflows by just dragging and dropping. So after that, what second node exactly does is that set a research topic. So here you can see LLM in education. So this is my research topic. I will zoom it. Okay. So this is my research topic. LLM in execution, AI tutorialing system, renewable energy grids, smart grade optimization, and faculty development with AI, right? So this is the topic where we need to add here whatever the topic, whatever the research papers we want, we can add here, and a email where we need an mail where a email should be sent, where the answer should be sent, where the final research paper should be sent. That target email we should be adding here, and minimum relevance score we can add the score here, and maximum papers. How many papers we want? A number of n papers, and here an API key is there. Now for currently, just ignore it. Uh, what exactly the API key is? I will move at the last what exactly the API key is and what it is. So we are not moving any technical part. It is basically a simple a text box where we need to add our own subjects. We need to add our own topics where we need to search that research paper. So this is about the second node. Now here it is a first source. Here it is a second source, right? So in this way we can add a number of nodes. Like we need to add in between like Google Scholar, like I need to add and like number of an top whatever the research paper websites are there. Like I want to add a PubMed, I want to add an IEEE Explorer, I want to add an JSTOR, like I want to add an DOAJ. So these are like number of an websites where here they will be adding here how many resources you want, where how many resources how many resources are there where you want to accept all the research papers from there. So these are the nodes where you can add the input one, input one, and input two. In this way, you can connect a number of an inputs to that number of an inputs. So when I open this node, here you can see the content, you can see the input, the topic where it is searching what exactly a research paper we want. So according to that research topic, it will be searching, it will be adding the score, and this is all about some basic parameters are there. So this is about the third nodes, where this is about the third phase where we can add a number of n resources. Now all the research papers are there. It is merging, right? It is merging. Like I got an 8 research papers, and I am merging that all papers. I'm merging that all papers, and in this way, whatever the parameters are there, the link, the title, the published date, who is an creator, what is the content in it. So in this way, after merging the PDFs, we get all the content from it. Now reviews. What exactly the reviews are is we are reviewing a paper, limit papers for the review. We will be not taking all the papers, right? So some of them are good, some of them are we don't need that context. Only related papers only we are taking it, and we are starting onto it. And after that, using an LLM, N10, the app is called as an N10 app. Using that LLM, what we are doing, whatever the 8 papers we got, we are taking that context, we are summarizing the whole things. We are summarizing the whole thing, and what it does, it attach the metadata, and it checks our topic, and it will compare whether whatever the summary we are getting, it is matching with our questions or not, right? So it should be very interrelated, whatever we are searching. So here, whatever the papers I have got, the papers link are there basically. The papers links are there. So this is a papers link. So here, there is a no point where it does not provide a lot of confusion. It is very straightforward, like railway boxes, where at the last, what it does is that it ranks the paper and build the digest. Whatever the papers we have got, it will rank a paper. You can I will tell. Just ignore for this. Ignore a code for this. We can rank a papers. What paper is like first rank, second, third, fourth, fifth. We can set an priority. We can set an priority onto it, and after that, what we can do, it is a relevant paper, right? Like we have searched regarding the uh, regarding a topic, and answer is it's relevant. If it is relevant, then you will get a mail. If it is not relevant, then it goes that no digest needed, because this workflow doesn't give unnecessary what we can say content. It will sort of everything. It will sort of everything. So Yesterday I was talking that we are interested, we means although we are a faculties, but we should be solving the problems. We should be making a daily life easy by utilizing uh, utilizing the site platforms, utilizing these AIs. So now I will run this workflow. I will execute this workflow. Now here my topic, what exactly is LLM education, AI tutoring system. So this is my topic, right? So I need a related research papers. Now I am executing the workflow. You can see a green one, right? So this now here the mail has been triggered. Now uh, you can see a green border, green line, how the work is executed, and I got a related workflows. Right now, I will go to my mailbox. I will refresh it. Now see here, I have got 8 relevant research papers. Right. So what exactly 8 relevant research papers are? Research paper digest topic: LLM is education, AI tutoring systems, renewable energy grids, smart grid optimization, faculty development with AI. Now I got these 8 papers. I got a summary also here only, and why it matters, and a published and relevant score 9 out of 10, 9 out of 10, 9 out of 10, and 9 out of 10. Right. So here, when I click to this link, here I can see that a data where what we can say a relevant LLM context I am getting, a relevant research papers I am getting from that resources only. So for now, currently this is in a beta version where means I have built for understanding how exactly this SaaS AI and there are the many other things like we can create a automated workflow. So now what we can do is that I don't want to trigger a workflow daily. I want a cron where every Sunday this should be triggered. I need a mail at only every Sunday. At my holiday time, I am getting my mail. Every Sunday, I will be getting my mail. This will be running 24/7. At every Sunday, you give one topic. At every Sunday it goes, it research, it checks the research paper, whatever the new research papers are there, it will extract and it will send the mail to you. Means, see how much the work is, the manual work has been reduced, and uh, by what we can say by enjoying your days at that time, particularly if you want a mail at 10 a.m. morning, so you can set the timing also here. Okay. Okay. Now it is a platform of N10 platform it is. Okay. Right. So in this way, this is a one way where I took a problem. I build a solution. I build an automated workflow where I'm a faculty. I'm interested to read the research paper every Sunday, like reading a newspaper daily, right? So in this way, we can automate anything. Like if we want like how much a productive time I have been spent, like what a research I have did daily, you get a weekly report also of your self evaluations. Like you can grab your Google story, you can grab your whatever the searching story is that in that after that getting a metadata, after that getting a data, you can create a self workflow where you can check how much productive time you have been spent, how much time you have where you have been wasted, what exactly things we will be do we have done at last week. So what how much what means the way of and progress how we can. So in this way we can create a self workflows for us only directly. So this is a simple workflow where I think I have explained in a better way where the most of the things I have kept very simple here. Like I don't want to go in the tech part, and this you can create using the Claude AI directly. So here uh, what exactly there is a one option like connectors. When you go to the connectors, when you browse the connection, here you can search N8N. So here after searching, you can directly connect here. And after directly connecting here, what we can do is that after directly connecting here, so this needs some authentication stuff. So after connecting here, you can directly give the prompts here that this is my problem statement. I want to create N10 workflows. So what exactly Claude will do? It will create every node for you without dragging and dropping, without adding the context unit, and it will debug automatically. It will create the workflows. Just you need to test the workflow. What exactly we need to do is just we need to test the workflow. Like if anyone has took a Claude subscription, that you can try, you just create a simple workflows using the prompts only. You don't do anything, you don't write any code, it will write the code automatically. Just you tell this is an error, we can check the output, we can share a screenshot to it. It will automatically debug, it will automatically create the node, it will join the nodes. Just what our duty is that run the workflow and check the output, whether the mail is getting correct or not, whether the information is getting correct or not. You should have some context about it, what exactly you are doing, what problem you have, and you need to debug at every step. Like whatever the errors are coming, just pick that error, give to the Cloud AI. So this we can do, and we can try a simple workflow from our side. So this was the a real world problem where most of the faculties face, and I have tried to solve this problem. If need this workflow, then I will share one file directly, you can import. And no, we don't need any subscription. We are getting the 14 days free trial, and we can change the email after every 14 days if we don't want to give any subscription money to it anytime. So I especially work totally on free. So whatever the workflow is running, there is no cost. It is running in 0 rupees. Like currently, I won't giving any money to API key also, like any LLMs also. So this is totally free. This is totally free. We can try with a totally free also. We can create a different 10, 14 emails. Like if our work's done, then we can degrade our emails. So this is one thing. Another, the way is that if you are using these workflows for the long time, like years and years, so like uh, I think it costs more than 4 5,000, and we can deploy it for the year directly. So subscription is also very less of this N10 workflow we can take and we can use directly. So this is a problem statement where I have solved. If anything, any doubts are there, so you can just ping in the chat. So how we can tackle that also. So whenever you are creating a new account, right? So after creating a new account, here the three dots are there. You can create import a file. I have this .json file, right? So this is a workflow. Now how I can get that file? What we can do? We can just what we can download. Click to download. The one file will be there, right? So if I will be sharing this file with you, you can directly create your account. You can go here, you can just click to import the file. Now whatever the file I have been downloaded, you can directly import that file here. So I will import that file, so you can see now what it has done. What exactly now here I can see a second workflow. You can see the magic, this is my second, this is the file workflow basically, and this is my original workflow. So it is not a very hard part to create a workflow, to automate the things. It's a very easy part. You can go, there are the certain YouTube channels where they are teaching in very easy way. Means what we can say, you can learn very easily about this. So uh, if you want to create a workflows, if account has been the free trial has been expired, so directly you can download this file, create a new account, directly upload this file, then workflow will be seen automatically. So this, I hope I have answered the question. Yeah, if any questions are there, then please let me know. Just unmute, and we can move to the second problem also. What are the other tools available for creating workflow? Uh, for now, I prefer N10 only. Uh, and like what we can say, other platforms are there, but the freedom N10 will give integrations, the number of tools the N10 is giving. So other tools are means other SaaS platforms are not giving much freedom. The N10 is giving more than 500 integrations. Like you integrate with the Slack, Google Calendar, you integrate with the databases, you integrate with own WhatsApp also. And another thing, I'm not getting the magic link of my email N10. Okay. We need to check the about I need to check out why exactly you are not getting the link. And server URL for the N10 is that yeah, we can deploy and we can share the URLs with the other people also, where they can also run your workflows, and uh, you can also rent this in the subscriptions. Like for example, I have made this workflow and it is really solving very good problem. Then just by sharing the URLs, I can take up any with that. Okay. Are there any questions like can you share this workflow file? Yeah, definitely. Definitely, Dipti. I will be sharing this workflow to Vipul sir. Sir will be uh, sending you in the group. Uh, yeah. If any other questions, then I can wait another 5 minutes and we will be moving to the next problem. Cloud is asking install anything. Installing anything. I will make some additional information. Okay, Sandeep, actually, this is a part comes under the configuration, so I need to check by on your system directly. I can't tell orally, right? How to create an N10 account. Uh, uh, you can follow tutorials, Vipul Kumar. I think there are the certain YouTube channels where they are teaching you N10 how you can create, how you can set up, how you can create the notes, and how you can do the configurations. Okay, if there are no more questions, then shall I move forward? Which is a better chat GPT or Cloud or Gemini? Depending upon your use cases, Dipti. What exactly, what we can say, input you are giving and output you are expecting. There are certain categories like in the A sector of in the sector of maths or English or writing the code. So this matters. So in the yesterday on the previous session, I have told that uh, choosing a tool is also what we can say. It is a bit tricky part because depending upon the use cases, what exactly you are using. So uh, every tool, every LLM has a certain benchmark. We can go how much accuracy that tool is giving for in the area of mathematics or like giving the critical answer, solving the things. Yeah, I will be sharing the resources regarding the N10 to Vipul sir. So whatever the resources need to learn this N10 workflows. That's it. Requires multiple resources for platform. Fact statements. We can add a manual node where like you can check and you can approve or disapprove whatever the research papers are there. So this one thing we can do. Okay. Now we will be moving for the second problem. Yesterday, whatever uh, the discussion we have made in the sessions. So, the students, the assignment, and the faculty, a very interesting problem. So, what exactly here is whenever any assignments or what we can say any manual books or we are be submitting for the faculty, there is a huge number. We have a different departments, we have a different what we can say classes, and a number of students are more than hundreds. Like so, how we can do? Like if I go in the manual way, I will be sitting, I will be checking every black book. I will be checking whether he has been done in a proper way or not, indexed. a format is there, a conclusion is there, index is there, title is there, procedure is there. So whatever the fact checks the faculty is reviewing, so that we can automate. Like faculty receives 500 plus assignment PDF from the students. Each file must be opened and reviewed manually. Significant time is spent checking basic requirements such as in word count, required sections, citations, and the formattings, whether they have done in a proper manner or not. Whatever the manual thing, whatever the time we are wasting, I have automated. I have made a workflow for that also. I will show you. It is a very means what we can say. It is very easy way. In the very easy way, it will take more than 500 PDFs, more than 1,000 PDFs at a time. It will download, it will extract the text, it will check the sections. This section is present or not, the conclusion is present or not. It will not go to the content, but it will take an overview whether whatever the assignments they have wrote, whatever the report they are submitting, it is in a correct format or it is in a wrong format. Like a feedback is often delayed and may vary between the submissions. Now, what exactly the workflow solves? What it does? It reads all the PDF from the Google Drive. Like I have made one drive. I have made one drive. I have made one folder here. Like CS 401 assignment one submissions. I have uploaded the two assignments. I uploaded the two assignments. In this way, many students will come and we are sharing the Google Drive link to them. They are directly uploading the assignments and we are getting all the list of assignments here. So this is a drive, this is a document, and after that, extract student information from each PDF, identify student name, roll number from the file name. So here, whatever the file naming convention you can see, Priya Sharma underscore 21CS402. It may be a roll number or it may be a unique number of that student, and it is assignment one. So from the file name and from the PDF content, whatever the information is there, we are extracting the information from there. After identifying a roll number and the file name. Now, AI based assignment review. Now, what exactly it does? It checks the word count, required sections, citation and the reference, and AI uses disclosure. I I created two documents. One document is in Rahul has created in very good manner. Now, suppose he has made one assignment or he has made one report where introduction, methodology, analysis, conclusion, and reference. So faculty is giving a certain sections where they have gave a format. This format should be compulsory in your report or in your assignment. Like he had did this assignment is correct. Now Priya. Now she has wrote only in a very generic way. Now, right, when we are evaluating this uh, when we are evaluating these assignments, so in this type of assignments, it may be a number of an assignments, right? So we need to automate this. We need to automate this where we won't be sitting at one place. We will be checking. We won't be checking the all assignments, and we will be won't spending much time onto it. Now, what we can do is that it will check all the sections. It will generate a report onto it. What report it will generate is that, like for example, now we are considering two documents, this one and this one. Whatever this type of documents are present in the list of an files, it will send a mail to the faculty. Please you check this student assignment. She has wrote assignment in a wrong way, like these sections are missing, this part is missing, and whatever the assignment she has wrote, whatever the report she has created, it is in very a wrong way, like it is not matching as per the criteria the faculty has set up. All right, what it does, uh, it it checks what we can say, it separates the two part, like okay if green and flag if red. If flag is red, the email will be triggered to that faculty directly for reviewing that assignment. And if all good, then directly it will be passed it and faculty don't need to review the assignment again. So if we want here also another check, then we can add another workflow. We can add another note to it also. Okay. So this is a problem statement we have to. And what exactly we are solving is that we are solving this one. So instead of an reviewing all the assignments, we have created automated workflow where at a time it goes to the 100, it can counts to the 500s also. At a time the workflow triggers, it will check, it will check all the assignments. If whatever the reports are there, if they are not looking good, they will it will trigger a mail, and it will send the document, that it will send the student details, and whatever the sections they are missing, it will also send that metadata also. So what benefits are there using these workflows? Like saving hours for the manual screening, ensuring consistency, Rubik checking. So Rubik checking means the basically these are the Rubik checking. So this section should be mandatory in my assignment. Help faculty focus on evaluations rather than verification, right? And speed up the feedback and grading processes, automatically identify the assignments and needing attention. So these are some points where I have to, and now we will go to the second workflow. So this is a workflow. This is also a very simple workflow. It is not a complicated workflow, right? So here, first, same, a start node is there where a workflow triggers here, a workflow starts here, and it sets a grading config. Like a grading config is that this is a folder where I have all the assignments. This is a required sections I need in that assignment document. Like introduction I needed, methodology I needed, analysis I needed, conclusion, and the references. So these sections are compulsory. I need this section, right? See, must cite at least three resources. Must include AI disclosure statements and a faculty mail. A faculty mail where I need a mail, where I need a mail. I need to send the report, right? And after that, these are the drive ID, and this is an open API key. So these are the both sections where this is a whole parameter about the second node, whole parameter about the second. Now, what the third node is, third node, what it does is that it lists all the folders. Now, how much the folders I have, how much the PDF files I have, it lists all the PDF files. So here currently I am getting two PDFs. One is an Priya Sharma PDF and another is an Rahul Kumar PDF. So what this node does, it will list all the PDFs. Now it will split the files. Now it will split the files that like I need only the PDF files. I don't need any other files. Like student are inputting like JPG images or any other word file. So that this workflow won't take. So I have wrote the condition there, and after listing all the files present in that folder, it will extract a text from all the PDF. It will extract a text from all PDF. So this is a data one, this is a data two, right? And it will parse the students from the file name. So ignore about this code. So this node, it will check a students from the file name, what a meta information I can get from that file, and a Rubik check, as I told, a Rubik check. So here there are the certain like introduction, methodology, analysis. So there are some checks, and at last a report is generated. If any submission flag, like now this whatever the report and assignment the student has been uploaded, it is not right way. So this should be shown to the faculty that this report is generated in very wrong way. Now, how I can know? I will start the workflow. I will start a workflow. The workflow is triggering. It is running now. It is evaluating. I got a mail. What I got a mail is that whatever the document she has uploaded, you please evaluate this document. Now what I will do? I will check my mail. I got an mail. Assignment pre-check. Now what exactly the mail contains? Like assignment pre-check report, assignment AI ethics and assignment, student name, student roll number, a file name, the words containing. It will generate a score also upon depending upon that report. Status is flag. Issues: missing required sections, insufficient word count, Rubik compliance issues, and recommendation. review for the major issues and provide guidance on the required sections and the word count. So so we can see, right? So just by running the workflow, at just clicking one button, you can evaluate the number of an PDF, number of an assignments are one at a time. You don't need to sit, you don't need to count all the what we can say uh, evaluation unit. You don't need to check every paper, every section or every page. Just upload your files on the drive, just click the workflow and you will be getting an output. So this is the second problem of N10. Means now I think the most of the people have got a good idea what exactly the problems this N10 solves. And this is not about a faculties where many of an industries use this N10 to automate their things. Like we especially provided one service to a particularly client where we automated whole digital marketing agency. This workflow automatically take a content Claude AI. You can go here. You can add that connector. Sorry, my bad. You can add that connector here, N10 connector here, and you can search here by just adding to connect. After connecting, you will be listing all the connectors here. So here I can see I have a Canva connector, I have a Google Drive connector, Notion, Slack, Atlassian, and a Canva also, like a Notion also. So the number of tools you can integrate to the Claude AI, and you can create workflows in this way. And after creating the workflows, what we can say is that you can check the outputs also. So this is about the second problem, uh, where I think I have tried to solve most of pain problems of an faculties and of students also. I will try to examine the problems of exactly it is, and if uh, if possible, like institutional problems, like institutes are facing a certain problem where most of the things are going in manual way. You want to reduce the time there, so we can create an automatic means automations, anytime workflows, or we can go uh, it is basically a tip of an ice. So at the bottom, there are the number of things that we can do. We can create an own in-house automation system, an autonomous system where it communicates with each other. It will check the every tool, and it will get the output there and till where the results we won't get, and it will start uh, processing till we won't get the results. So uh, I think I have explained the second problem also. If any other questions are there, like I have this problem, I want a solution for that, then we can discuss here only. Uh, Regarding the results, every LLM perform in a very different way. Uh, so the results may vary, sir. Surendra, sir. Results may vary, and we need to do some R&D onto it. So if you want a good, accurate result onto it, yeah, welcome. Yeah, if any faculty member has any doubt or any person has any doubt regarding these two problems I have shared with you, uh, so you can unmute, and we have another 30 minutes, so we can discuss the problems on more rather than delivering the general context, what exactly the AI is and how almost everyone knows about how everyone knows number of tools and the models also. So uh, leaving that, it comes under the technical part mostly. It comes under the what we can say implementation part. So I think what we can say, if any problem statement you want to discuss, then please unmute, and I will be happy to help you. Hello, am I audible, right?
Yes, sir. You are audible.
Yeah. Okay. I think I have delivered the most of the content. Like, if regarding anything, if anyone has any doubt, then we have a time, so we can have a discussion on it. Local, we can install rather than saying installing anything local. I prefer that you go to the cloud directly, Sandesh, because why? I don't know about the hardware configuration, what exactly you have. So rather than keeping the system alive alive at for the time 24/7, you go with the cloud. It will be a very much easier rather than installing all the stuff at locally. Should we create an account and it can access the servers? Sorry, can you unmute yourself? Actually, I want to know more thing about what exactly you are doing. Means what exactly you are asking about.
Yeah, am I audible?
Yep, yep, yes.
I just went to the cloud, and as you said, no, I gave that connector,
Mm-hmm.
N8N connector. When I gave that, it's asking give the server URL.
Yeah, we need to create that account first. So I will share my screen. Server URL is a URL where,
Okay,
so yeah, this is your server URL basically.
right.
This
So
is a
how do
workflow
I
URL.
create that? That's what I didn't
Uh,
get.
yeah, actually, I need to debug that. I miss. We can after this call or after this session. So you can take my contact. I will be helping with. I will be helping to resolve this issue. There will be no worries.
Okay, okay, fine.
Thanks. Please explain a simple task how to generate a workflow using Claude and how to run in anything. Uh, See here, it is bit time consuming because why? Plot takes a certain minutes to write and code, to test and to debug. So it will be a different session basically. So hands-on experience, live hands-on experience is basically a workshop. So in half an hour, I think it is difficult to cover that implementation. So we need 1 or 2 day workshop on the NTN especially. So I can show you all the possibilities where how to create NTN workflows on Claude and how we can generate the JSON code just by the prompting to the GPT or just prompting to the Kimi AI, right? So and adding the uploading the file and triggering the workflow. So basically it is a game of like understanding the problem statement, generating the code, or adding the nodes and debugging and testing. And after that, yeah, you will be getting the solution. I hope I gave the answer. Madhu. Yeah, thanks. Okay. Yeah. Uh, Apart from this, what exactly I can tell is that uh, many of the companies like they are doing the major layoffs. So I want to discuss on that also. So many of the students are telling that AI are taking a jobs, AI are taking. So basically, the concept behind that is a very different one. So why? Because this is a very interesting topic about it. This is a very interesting topic because see, most of the freshers jobs are vanished. Vanished in the sense like uh, the whatever the freshers the task they are doing already the cursor already the other tools are there. So that is the reason where whatever the interns work interns work whatever the company needed at in the previous years. Now they won't need. So here, how students should act means what exactly now current situation is in the current job market regarding that, in the IT or in the ENTC, like, or in the any another field it may be. So utilizing the AI and clearing the concepts, upskilling ourselves, whatever the time we needed for the upskilling, it has been reduced now, because what we can say is that, now if I want to learn any concept, we don't need to go to YouTube. We don't need to search that topic directly. We can prompt and we can clear that concepts in very easy way. So now I have seen number of my students, like recently only Oracle and another one two companies, they have gave an offer to IITs and NITs, and they have revoked their offer, and they are telling that, we are restructuring our company, we are integrating the agentic AI, so that's why now we don't need you. So NITs and IITs has blacklisted that companies currently. So what exactly the companies are doing in the COVID time, over hiring was done. Over hiring was done in the COVID time. So now they are removing the peoples. Uh, now they are firing the peoples, and whatever the simple tasks are there, whatever the simple tasks are there, writing the templates, writing the boilerplates, AI is doing in very easy way. So now, uh, how exactly we need to upskill that, we need to go, I especially talk on regarding a tech on seriously only, means I have some expertise onto it. So rather than what we can say, starting the things from the base, what we can do is that, what students can do, what we can prefer to them is that, don't go in very generic way. Now full stack development, web development, application development, they're outdated. They're totally outdated. You built one website, you are building one website, you will be adding your resume, and you are applying to number of companies, and you will be getting rejections, and you will be blaming, you are the blaming that AI is taking my job. So no. So now currently we need to upskill and we need to learn new skills like LangGraph, LangChain, and there are the many frameworks where you can build your own AI systems, rather than using an AI. And rather than using an AI, if any person is building an AI, the scope of area will be more to that person in this market currently. So there are number of tools, number of people are using, but a customization, if any person has an expertise where taking a problem, doing the customizations and creating the AI agentic AI workflows, and uh, giving the solutions to that company, then company will be definitely hiring to that people. So there are jobs are there. That means, we cannot say that there are no more jobs. AI is still so. Uh, uh, in middle also there are the certain news spread, like uh, a cursor AI and other tools they are using blindly. Whatever the companies are using blindly, that that tools have deleted the server databases. Means, deleted the databases in the servers, like for example, you are using like a phone pay, you are doing the transactions, whatever the transaction we are doing, it is stored in the databases, like, right? So whatever the real time production databases is there, so AI is deleting that. So there we can't take a risk. There human interventions engineers are definitely needed. Here, how the evaluation is, how what we can say, how the flow is changing is that, at the previous time, we will be doing the hand code manually, but now we can speed up that. We can build the things very fast. But whatever the checks are there, like the best practices, whatever we need to follow, that should not be losers, right? So these are some points where I need to highlight. There are the jobs AI will be won't taking any job, uh, if you are using in efficient manner, if you are solving a problem in very different way, in very unique way, then definitely you will stand out from the crowd. Means definitely the students will be standing out from the crowd, and they will be getting the good packages, right? So currently there are number of companies they are hiring for the AI engineers for the freshers also. I have seen number of openings. I have seen for the ENTCs also. For the ENTC people also, like if they are interested integrating the AI in the IoT. Like I want to integrate a AI in the Raspberry Pi. I want to integrate an LLMs in my custom motherboards. So this is also be done. This can also be done. Integrating an AI with an with a components and what we can say with circuits with motherboards. So we can create a IoT systems, AI IoT systems where it communicate with each other. So recently, my friend was solving one problem. They have built 3 4 prototypes that that product will check a atmosphere, a temperature, and the 3 4 nodes attached in the different areas, they will communicate with each other. They will communicate with each other. They will share the data together. The 4 nodes will be sharing data together, and daily data will be sending to the admin, to the uh, climate department, where they are checking that data, they are making analysis, and they are giving the precautions, what exactly precautions we need to take, and how much rainfall it is predicted. So means basically a helping hand. AI is doing an helping hand. It is not autonomously doing work, and it is giving results. But in this way, there are the many projects we can students and the faculty can bring onto it. They can sit and they can create a good projects. And I have told that NVIDIA is also a good platform where we can go, we can check, and we can get the simulations. We can check the simulations. So I especially I'm exploring now. I'm new to it. So if in the future I get any chance to deliver on the NVIDIA or in the simulations or in the ENTC part, so yeah, I will be happy for it. And I especially now currently moving to physical AI, gaining the skills
Sorry,
more
is it
onto
free
it.
with NVIDIA this one? Sorry.
Sir, yeah, the most of the parts are free. Like if you want to,
Like, can we use it for our lectures and student projects?
it is basically for building a prototypes only. So for the minimal use, I don't think so. We have the services here, like they have their own LLM models like Nemotron. They have their own LLM model, so we can use for it. We can use for other it, but most of the things, the NVIDIA and uh, the services are like building the products only, basically building the AI products, building the autonomous products in the various sectors, in the manufacturing, in the healthcare sector. So recently they have released one tool where uh, whatever the pattern, DNA pattern, uh, every DNA has a certain pattern, right? So just whenever I am giving input a pattern, input number, input DNA number to that model, it will draw a 3D structure of my DNA, and I can see where my DNA is broken, where my protein molecules are breaking, and where a DNA is in proper structure. So in this way, they are doing the advancement in various sectors. So currently, now in the next few years, physically I will be in very boom. So now in the ENTC part, about talking about the ENTC part, the things, the motherboards, the components will be releasing by the NVIDIA, where we can take, we can use, just we can program and we can simulate, and we can set up a system where uh, it does everything onto it. So yeah, I think I have delivered the most of the things. I have gave my best to share my knowledge, whatever the industries, whatever the things I am working on to it. And if any help needed, or we need to upskill, or I am not understanding this concept. So if any doubts are there, then you can reach at any time. So I will share my LinkedIn profile also with you panel, and yeah, always be happy to helping to all of you. So yeah, I think Vipul sir, I am done from my side. I have delivered the most of the things, and if any other suggestions or any other things that remaining, then I will be there till 3:30 here.
Thank you, sir. Participants, if you have any question, you can ask.
Thanks.
Yes. Thank you, sir, for guiding us how to use AI tools for writing research paper and evaluating students' assignments. Once again, thank you for your valuable insights and meaningful contribution to today's session. We truly appreciate your time, efforts, and knowledge sharing. Thank you, sir.
Thanks, man. Thanks. Okay, I will be there in the call till 3:30. So if any doubts, then please, I will be happy for it.
Okay. Participants, be there. We will start our second session.
ನೆಕ್ಸ್ಟ್ ಟೈಮ್ ಮಾಡಿ ದುಡ್ಡಲ್ಲ ಎಫರ್ಟ್ ನಿಮ್ಗೆ ಹಾಫ್ ಅನ್ ಅವರ್ ಅಲ್ಲಿ ದರ್ಶನ ಆಗುತ್ತೆ 3 o'clock ಒಳಗೆ ಹೋದ್ರೆ 3:45 3:30 ಆಚೆ ಬರುತ್ತೆ
Hello, everyone. We
full
will
free.
start our second session at 3:30. So we will have a 10-minute break now. So all have to join at 3:30.
ಈ ಟೈಮ್ ಸಿಕ್ಕಿಲ್ಲ ಅದು ಏನ್ ಗೊತ್ತಾ 3 ಶಾರ್ಪ್ ಲಾಗಿನ್ ಆಗಿ ಇಟ್ಕೊಬೇಕು ಮತ್ತೆ ಎಲ್ಲ ಡೀಟೇಲ್ಸ್ ವರ್ಡ್ ಅಲ್ಲಿ ಇಟ್ಕೊಬೇಕು
I think Anjali Deshpande need
ಅವಾಗ್ಲೇ ಆಗೋದು ಇಲ್ಲ
a walkthrough on the workflow once again. So,
ನೇಮ್ಸ್ ಆಧಾರ್ ನಂಬರ್
like Anjali, can you please unmute yourself? Uh, I will help you. No worries. Able to create. Uh, Vipul Kumar sir, we can have another call after that, after this session. So I will be resolving all your issues. So you can contact me directly. Oh yeah, regarding the cloud configuration and anytime connections, we need to do some configurations onto it. So I will share the resources where how you can connect it, anytime to the cloud, and there all the steps will be clear. So I will be sharing you all resources to the Vipul sir, and yeah, I will convey this message to the sir to forward all the stuff.
Hello, everyone. Hey, good afternoon. Good afternoon. Sorry, I am a few minutes late. I am jumping in from another meeting.
Okay, sir. No issue.
Yeah. So I don't know if somebody
Which
is
I will
going to
introduce then.
meeting, or is that something that
Yes, sir. Sorry.
is somebody is going to anchor the meeting?
Yes, yes, yes. I'm going to address it. Wait.
Sure. Right.
So welcome to all in the second session of our FDP. It is my honor and privilege to introduce our second guest, that is Mr. Jaykumar A. Krishnaswamy, CTO at AILA CDS Pune. With over 20 years of experience across the manufacturing, insurance, and telecommunication industries, Sir holds master's degree in artificial intelligence and machine learning from Scalar and postgraduate diploma in business analytics from Symbiosis International University. Sir has developed deep expertise in IoT machine learning, big data management, technical architecture, and programming in R and Python. Also, Sir has worked as a data scientist and AI trainer at Freelance Pune, Deputy General Manager at STL Steroid Technologies Limited Pune, Vice President Product Development at Swiss Ray Bangalore, also Business Development and Pre-Sales at Cognizant Chennai, also Software Engineer in Exaware Technology Chennai, and he also worked on various positions in John Deere also. So with this, I now invite Mr. Jaykumar A. Krishnaswamy sir to begin the session. Over to you, sir.
Thank you, Priyanka. Thank you, everyone who has joined. Thanks for the kind introduction. I am Jaykumar Krishnaswamy. You can call me Jay. So today's session that I chose to take was around what we call as RAG systems, RAG systems, and agentic RAG systems. I know there is a pattern with which everything is going, and I am assuming that the introduction of AI, about AI machine learning and AI agents and the differences between them has already happened. This is my assumption. You guys can correct me if I'm wrong. If something is beyond what you comprehend, please let me know. I'll try and bridge that gap briefly. But today's whatever session that I'm going to have for the next 1.5 hours is going to be focused on what we call as RAG systems. Can I ask like open questions to the audience? Like if you guys can answer it in the chat, we can make it a bit more interactive, if that's okay with all of you guys. So I'll start with this open question: is does anyone know anything? Do you know what RAG is? What is RAG? RAG? Okay. So there is a lot of no's coming. Any yeses? Retrieval augmented generation. Yes. 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 The RAG stands for retrieval augmented generation, and why it's so special and what it can do is something that we will see now. Okay. So before I get into RAG and all the details about RAG, I also specific answers from huge database. Yes. Sweta says specific answers from huge database. That's pretty much it, right? Like when you have huge amounts of data and databases, and specifically, okay, I have this question. Specific answers from huge database. All our RDBMS database does the job, right? There can be huge databases with RDBMS type systems, DB2 mainframes, Oracle systems, any kind of databases that we do. They have huge amount of database. So what is special here? LLM and custom DB. Okay. Okay. Custom database. Okay. So I would say it's I wouldn't say custom. It's a combination. So when you have a situation where you have unstructured data working together, this typical RDBMS systems, what it does is it throws all the bunch of text and image files and everything that you give into something called blobs, okay, binary large objects, and they just throw it in a file or a set of file or into a file system, and they just create a link with the structured data to the unstructured data. That's pretty much it. So all it can do is that if you have a traditional RDBMS system, you'll be able to link a record to a file, and that's about it. You may potentially retrieve it back, but you won't have any intelligence about like the contents of it. And you know, if you want to search inside the document, you don't have any other options. You know, there are some restrictions. Then, so this is the traditional RDBMS world. Then came the world where people started talking about NoSQL databases. NoSQL databases where you don't have to write a SQL query to query the database. So it was, I call it a lazy developer database. Okay, meaning developers who are lazy enough to learn about RDBMS and database systems created this idea of just capturing things in terms of schemas, which they write it in classes, and they just wanted to download that structures into files, and then you know, have that associated data sitting along with it, so that you can, you know, pull it out. The typical JSON structures, XML structures that you have to deal with when you write programs and stuff like that. You know, they didn't want to like deal with RDBMS structures in terms of, you know, primary key, foreign key relationships and checks and balances and integrities and stuff like that, because they wanted to move fast with development. So that's why I call it that lazy developers databases. But that's just my term. But various different technologies came through, which is like CouchDB, which is MongoDB, which is now called, I think it is called AtlasDB. The various different types of databases came, which handled this type of very different style of holding data. But end of the day, they were still structured data, which means that even a JSON structure is a structured data. Only thing is you didn't call it as columns and rows and put values inside these things. So that is the only difference. But it was still structured. So truly unstructured data started emerging when HDFS systems, the so-called Hadoop systems, started emerging in the field. So Hadoop, I don't know if you guys heard of Hadoop. This is many years back. At the time, it was one of the biggest technologies. It's just distributed system, but you can arrange files in a linear fashion and you can scale it in commodity hardware. Earlier, that distribution was deeply held with IBM and these big companies. Hadoop opened it up, right, a little bit. Now things have evolved beyond that, right? Right now, you have various different types of technologies which have come. For example, Databricks has come up with certain technology levels where you can have Parquet files, and on top of that, you can have metadata, and the metadata can be shared among other systems. Among all this, development of databases came a situation where large language models started coming in, and large language models said that, okay, if I have to read something, I will read it only in terms of embeddings called vector embeddings. Okay, so they called it vectors and vector embeddings. What these things are and things like that, I will show you in a while. But once these vector embeddings started coming in, and large language models were basically what we call as AI these days, started answering questions that we have, and it tended to take data from these large language models. But these large language models were built by these large companies like OpenAI, Claude, and other people, Gemini, with a certain cutoff date in mind. So basically, they collected all kinds of data from World Wide Web and everywhere. They basically created these models from this data, and they threw away their data. Data is not required anymore once you created the model. But the limitation is the model's ability to answer questions to you is limited to the data that it's been trained on, which means there is a cutoff date. Let's say 2025, December 2025 is the cutoff date for a model. Anything that you ask about anything that happened in 2026, the model is plain and simple, not capable of answering your questions. And provided it knows something about it. So it will, but the models, these large language models, are trained using a technology called reinforcement learning with human feedback. So that essentially means that the model is trained to please human beings, you and me. It is not meant to give you the right answer. Okay, so that is one of the biggest mistakes people do, is they treat large language models like Google search, and they believe whatever the model is saying. So that is very dangerous. Okay, because these models are trained to please human beings because they need to survive. Okay, so even if they don't have an answer, they will not say they don't have an answer. They will concoct something and they will give you an answer based on the old data and patterns that they can find in the models. And this is dangerous for especially for companies which tend to take decisions on top of that, and definitely other, personally, you and me also. It's not a good idea to completely rely. Can we have everybody on mute if that's okay? Thank you. Okay, so this is also a problem, right? This hallucination was a problem. Now, other problem that started coming up is these large language models were good. They are good. They can answer questions. They are capable models. But they don't have information about, first of all, the latest information we have. Next thing is companies, big companies or small companies, anybody, they needed to use their own data, and they wanted to leverage large language models on top of their data. Now, if it is 1 or 2 files, you and I, we are familiar, we can just drag and drop it into ChatGPT and say, hey, here's the file, tell me anything XYZ about this, and it has a capability to do it. But what if we had 10,000 files? What if you had 1 lakh files, 10 million files, right? It's not possible, right? And why it is not possible? Because large language models, whichever way they are getting exposed to, they have limited memory space, which we call as context space. Now, all these terminologies are important when I start explaining RAG and how it works and all these terminologies are important. That's why I mentioned that if anybody has done some prior work on AI, if not, probably in your upcoming sessions you might understand a little bit more. But for this session, this is important to understand, is that these contexts are getting created whenever you interact with large language models. Now, these contexts never go away for one particular session. That means if you put in bad context information, you're going to get bad results. Okay, and it is limited. This context window is limited. Every model has this limitation. If you are interacting with ChatGPT or Claude through the browser, you will have a conversation with it and it will start answering that. So input you are giving is called an input context. Then the output that it is giving out in big verbose content is called output context. Then that is not the only context. The thinking it does, the reasoning that it does based on your questions and using its own data, it is also part of the context. So they generally, for commercial reasons and for capturing your and my data, they make it look like it is free, and they give large enough context for us to use. But that there is a limitation for it. Okay, there is a limit to this context. So if you are working with any of the frontier models these days, 1 million characters is there that is available for everybody. But that is also a limitation when you deal with 10,000 documents, 20,000 documents, 1 lakh documents, and things like that. And also, as I mentioned, if we start putting bad context, the model will start giving you bad results. So the question is, how do you put good context into the model? Okay, so that your answers are right. So all these things need to be engineered. It is not by chance, it is engineered. Now, when you want to engineer this such a system that works with you in these situations, then we have to build something called the RAG system. It's called retrieval augmented generation. So large language models, as I said, has its own limitations. And beyond these limitations, if you want to provide some additional documentation or content and things like that, how do you make large language models respond correctly to what you have with you, okay, without running out of memory and blowing up your builds and things like that, okay? That's the trick here. Okay, so okay, now I can share the screen and some content. Okay. What I will rely on is it's an existing. So we have a AI first coding course in our company, and I'm going to rely on the course content for this session. Why? Because it allows me to go and show you different concepts very, very quickly without breaking a sweat, because it is already there. So this is essentially a course. Module 2 is free for everybody, so you can go to this site and get to the course and see how AI agents are developed. Okay, so this is the initial module level, but then after that from this point onwards, it's behind a paywall. But you can build a prototype, and when you build agents, you can build prototypes using 2 different technologies. One is called the NA10, which is typically for people who are not comfortable with coding and who want a visual way of learning stuff. So for them, we have this section where it is NA10. But if you are comfortable with coding and you can work with Python, we have a Python version of the same thing. So it is up to you guys. What are you interested in? It takes into all the details. Okay, so I will not get into any of these details, but I will stick to the concept that we wanted to discuss, which is RAG. Among everything else that we discussed, RAG is the concept that we are going to look into. Okay. So I'm just going to borrow the content from this course that we have. All right. So, oh, by the way, I'm just opening the slides, but there are videos and text also. So, I mean, if those of you who want to watch it as a video, you can watch it as a video. Those who want to read it, you can read it. Slides are generally used by me or my instructors to teach. So let's talk about RAG fundamentals, okay? So when we talk about RAG fundamentals, one thing that we have established now since our discussion is LLMs has its own limitations. And when you have additional data you want to put and make the power of LLM to work on your data, and your data size is beyond 3 or 4 files, you have a volume of data, then you have a case for building a RAG solution. A lot of companies are looking for this type of solution, okay? And we do consulting and work on this space also. What are the learning objectives? We will look at what retrieval augmented generation is and why AI agents need to answer questions about your documents. So when I talk about AI agents, it is not your large language models. These are agents, again, these are structured agents which work with any kind of large language models. And I said there are two different ways which are there. One is Python based or TypeScript based or any other programming language based. Agent creation is possible on different frameworks. Or another framework which is visually possible is, one of them is N8N, but there are lots of other solutions out there in the market where you can build all these types of agents. All these things are available in YouTube. You already know potentially. So idea is that AI agents are slightly action-oriented elements, okay, modules. Large language models have an ability to just answer your questions. They don't take actions. AI agents have a capacity to take actions, okay? And that's the difference. And these agents that can take actions get supported by the knowledge from your documents through the RAG system. So they work hand in hand together, okay? When we talk about RAG systems, you need to understand something about vector databases. I already mentioned that large language models like to work and interact with something called vectors or called vector embeddings. You put a bunch of vectors together into something, it's called a database, basically. So like any other database where you have columns and SQL database and NoSQL database, vector database is also another type of database. Guys, I am assuming because of the answers that I got, most of you are not familiar with these terms. So I'm trying to be as grounded as possible, and I'm not rushing through. If it is boring and if you guys already know about it, please mention that in the chat and I can speed up, no issues. Okay. Is the pace okay with everyone? Yes. Okay. 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 Let's go ahead. Okay. So, so when we talk about, thank you so much. Thank you for everyone who are responding. So when we talk about vector databases and stores, you need to pay attention to embeddings and the dimensions. And what makes it fast, okay? The whole trick here is that even if you have millions of records, whether you are able to respond in a matter of milliseconds, okay? I'm talking about milliseconds. How do you do that? Okay, so you need to understand the game behind all this to be able to achieve that performance. Okay, so all right, so we will also walk through a complete RAG flow from documents to embedding. I don't know if we will have time to build one and show it to you and demonstrate it for you. I have the code, and the codes are all there in the course itself. All you have to do is download it and run it yourself. But I don't know if we will have the time to do it, because RAG is one and then agentic RAG is another. So in this session, we are going to cover two topics. So, you know, it's subjective if I will be able to show you a demo. Now, but I can show you where you can get, and then probably the code that we have, I can potentially download it and share it with the group, and all of you can have this code. So, okay, so then building a working RAG pipeline with the N8N. So again, N8N is a tool. It's as I said, it need not be N8N. It can be any other programming tool also. But the idea is that it is going to watch the flow that we have created and sharing with you. It's already a slightly advanced flow. It's not a typical RAG solution. This is something that you can actually use, or companies can use. Basically, what it does is so you have a drive, right? And new files will come into the drive, and it will keep watching the drive. When new files come, it processes it. Okay, when it gets updated, when files are getting updated, it knows that it has updated and processed. If you delete it, it will delete it. So it sort of syncs the database with the drive, right? So something like that. And processes them and stores them. Now, storing them can be in a database. Now, the database typically can be a Postgres database. This is what I prefer. Postgres database. It can be a SQLite also if it's too small. But then, if it's Postgres, you have to enable an extension called PG Vector, which means a vector database on PostgreSQL. Vector databases, there are lots of commercial solutions available. I think Pinecone, Quadrant, VV8. At the initial stages, there was something called Faz from Facebook. Plenty of people came up with plenty of solutions. But tried and tested, PostgreSQL has always been the database for many years now, and it's free, and it has PG Vector, which is a vector embeddings, and the solutions that we are building, it's working just fine. It's super fast. I don't find a need to spend money and subscribe and take something like a Pinecone or a Quadrant. Of course, the game will change if you're dealing with millions and billions of documents and things like that. Then you will have to go to that scale. But typical situations for any medium to any anybody who's dealing with less than about like a lakh of documents, it's good enough. Okay. Now that is PostgreSQL if you are running it in locally. Now same PostgreSQL, you don't want to run it locally. But if you want it to be hosted in cloud, there are various different solutions for that. One of them is Supabase. Supabase is they have a free version, so you can use the free version of Supabase. They take care of most of the things about security, about row level security, etc., etc. So they have all these kinds of fancy stuff. Underlying bottom line, it is still PostgreSQL. Okay. So either ways, you use Supabase or PostgreSQL is one and the same. The next thing that you need to pay attention to is what are the concepts that are involved in RAG. One of them is called chunking and metadata collection and RAG tool configurations that leads to agentic search. Okay, so that is something as the second part. Metadata collection, we'll see if it comes, but that is also typically needed into agentic RAG, but chunking is definitely needed for RAG. So what is chunking and all those things we will slightly see. I will not spend too much time on this, okay? So RAG, so what it does to your agent, okay? Basically, you can chat. Can we mute ourselves, please? Thank you. Okay. All right. So so as I mentioned, when you have external knowledge that you have with you, and you want large language models to be able to access it and work with it, but you don't want to share all the documents at the same time. You want to only select certain specific set of documents or sections of those documents to be shared, which is what chunking is all about. Even if you have a document and if you have chunks, only certain chunks will be shared with the document with the large language models. So that means all your data, all your sensitive data, you're not going to share with large language models at the same time. So that is a bit of security there, but that's the nature of a RAG-based solution. I'll just skip through these things. So, okay. So, are we already talking about? We are talking about, okay. So, even though we talk about RAG solutions, as I said, that you can add these documents, RAG solutions themselves has some disadvantages. Okay, what are they and what are that? We will see it later. But when we create a RAG-based solution, where RAG is okay for searching and providing information from your internal documents. But what about documents that are not in your premises? You might want to go out in the web and search and things like that. So that's why you have to generally when you build AI agents, you also, when you have a RAG solution, you also have a web search solution, which is not necessarily required. In many cases we will not, but in some cases we do. So AI agents can work with multiple tools. Okay, RAG for it is a tool. So is search. So is everything else that it's going to work with. So there are many tools that you can define for an AI agent. So I'm just saying that when we build a solution with AI agents, RAG is not the only solution we build. We build additional solutions also. One of them being web search tool. Web search also, there are options of relying on external APIs to do the search, or you can have a local web search engine running, which for free, which is called CRNG. You can try that. But there are options, is what I'm essentially saying. Brave API that we see here was free when we created this. Now probably they are restricting it, but there are also other free APIs that are available. Okay, so this is already we covered. RAG does not replace large language models. It feeds into large language models. Okay, how do vector databases work? Basically, there are three concepts: embeddings, dimensions, and nearest neighbors. Okay, embeddings is what forms the crux of the vector database. Okay, when you create a vector database, you use the embeddings, you put them together. Okay, but once you put them together, so when I say when you put them together, what I mean by that, I will explain a little bit. Okay, so when you interact with, or when you provide documents, okay, to any large language model, what it does is it converts the text into what we call as embeddings. Embeddings are a bunch of numbers, and that's why we call it as a vectors. The bunch of numbers represents the text that you have given, and which we call as tokens. Combination of tokens forms your sentences, and that means combinations of these vectors forms your sentences. And each vector, as I said, has it's a column, right? It's a column, which means there is in a column there are multiple rows, and each one is called a dimension. So the length of the column determines the breadth of your vocabulary, let's say. Okay, the more words you put, the more size you need to accommodate, right? So it's an analogy. Okay, but these vectors and these embeddings are not created only from one word perspective. It actually carries connections and context across all the embeddings that are there in the vector database. So they are already connected with each other, okay, in the form of numbers, and these numbers know each other. So this means that there will be variations and small variations between these numbers, which puts things together. Okay, so this all goes back to the original concept of transformers and attention layers and things like that, how large language models are even built. Okay, that is beyond the topic for now. But basically, when the model building happens, this is what is happening, right? So you have a bunch of numbers in terms of the vectors, and these vector numbers are calculated by the model. And why it is calculating this? Because it is trying to find association between words. Okay, and these transformers with attention heads basically determines which words are more important than the other. Okay, so this is the whole crux of what large language models are. But when we create all these numbers become vectors, and with these vectors have dimensions, and this dimensions ka size determines how large information you can put together in the space, and that determines the power of the model. So the larger the model, the larger the size, the powerful the model, more it's going to cost you. Okay, so that's the simple dynamics that you need to understand. I don't want to get more technical into this. So when we talked about dimensions, we are familiar with 2-dimensional, 3-dimensional. These are multi-dimensional vectors, which means it's in a hyperspace, which we cannot see because human beings have a limitation of seeing only 3D objects. Hyperspace, hyper objects you want to see, you have to only imagine. because this is our mind's limitation. But mathematics doesn't have this limitation. It can see hyperspace, or at least represent things in hyperspace. So what it all means is that these spaces is called vector embedding spaces, because the space is now having a lot of embeddings and lot of words. And it also, as I said, these embeddings have relationships between one word to another. And this is just what you see in the screen is just a representation of that, okay, for us human beings to understand what it is. Models and math doesn't require this representation. They know it. But for us to understand, this is about, so what I mean by associations is that in simple terms, when we talk about various different topics, each topics can belong, each words can belong to a topic. So for example, if somebody is talking about laptops and MacBooks and desktops and gadgets and all these things can be put together in clusters. It's just a representation, okay? Don't take it literally. But technically, if you want to represent it, if you represent it in terms of how you represent a vector, right, as a line with an arrow, which that means it has a direction, and that direction means two words together can form, you know, an angle between them, right? And depending on the angle that you see between these two words, to these vectors, you can determine how similar. Cosine similarity. This is a way to determine if a word is closer to the next word. Is it related to each other? Okay, and this is an important concept that has been applied in this type of spaces. Okay, to determine, okay, how is guitar connected to laptop versus how close gadgets is connected to laptop, or MacBook is connected to laptop. Okay, technically they are both devices. Guitar is a device and MacBook is a device. But to the word laptop, MacBook is more closely associated than the guitar, right? This is learned. We learn it by our experience. How will a mathematics model learn it? It learns by the distance, and the distance is called the cosine distance, and the distance is calculated by the vectors and the angles between these vectors. Okay, so so this way you can create multiple different sections, which creates multiple different associations, and it knows which one is far away from each other, and it also can have hierarchy. So like you can define something called a building, and then you can say a building can be anything, right? It can be a hospital building, it can be a school building, it can be your house, it can be anything. Anything is a building, right? Then you say a doctor is associated with that building. Then what do you think about it? Probably that building is a hospital. You make that association, right? So that those types of contextual association is what large language models are doing. That means even if you don't have, if you're asking about a question that the model is not trained on, it is able to make those associations, okay, based on the words that you type. That's the danger that we are talking about. The model doesn't necessarily need to have the data that you are looking for. It can make those associations and it will try and answer that question. And that's why it does that. This is all, conceptually I'm saying. But then generally there are these techniques called nearest neighbors, sophisticated versions of nearest neighbors, I will say, called ANN models and things like that. That is all used to essentially zero down on even. So basically, when you have a word, you want to predict the next word. That's how large language models work. But how will it predict? It will predict among a bunch of words, and those bunch of words need to belong to a particular neighbor in the cluster. And it has to do it fast, right? It cannot. So these things happen really, really fast. So this is basically the difference between how a traditional search, keyword search based work and the semantic search, which RAG does, works. RAG is basically does the exact same thing what we said, what large language models do. Because basically what you're converting, what you're doing with RAG is you're taking your documents, you're converting them into embeddings, and you're putting those embeddings in a vector space. And this vector space and embeddings is what the large language models understand. So the large language models can work with your RAG at a much faster rate than than you loading a document into the large language model, because internally it will convert that back into embeddings and vector spaces, and then it will work. Okay. So I want to quickly go to a space where, okay, these are all RAG and all these concepts, but how do you build it? Okay, what are the main components for building a RAG pipeline? Okay, so RAG pipelines have two different flows. One is called the ingestion pipeline, and another one called the query pipeline. Most of us are familiar with the query pipeline, which means that we ask questions, the answer comes to us, nice and nice. Okay, that's the last bit, the large language models, LLM questions and context, and you get an answer. This is the last bit which you are most familiar with. But there is this ingestion pipeline also. So basically, ingestion pipeline takes care of the process of loading the content. So when you have documents, you take those documents, you convert them into chunks. Chunks can be fixed length chunks, or it can be semantically determined, or there are various different kinds, okay, so of chunking. So basically, we chunk the documents with overlaps and things like that, and we create these embedding models. These embeddings models are vectors, go into a vector database, and this vector database is typically stored, as I said, Postgres or a Supabase with PG vector extension. PG vector extension is the extension that is coming with Postgres to handle vector databases. This also means that you can store RDBMS type data in a Postgres database along with the vector database. Okay, so now the equation is that you are not limited to only storing vector databases. You can have typical RDBMS, because even SQL databases has its own power. They have done wonderfully well for so many years, and they have served us so well for so many years. They are still consistent. So for example, now let me talk about the limitations of RAG. Okay. Now, if you have only RAG database, you can ask questions which are semantically related, okay, and association based on things like that, and it will have an ability to answer, even if you are not asking for a strict your question has to exactly match, as a restriction is not there. It has the ability to go beyond your limitation of asking queries. It can still try and find the right answer, and large language model is very good at that. That's why we love it. But the limitation is, for example, if you have a table of, let's say, 1 million columns, and you want to ask a large language model, okay, this is a column of numbers, calculate an average about it of this thing, 100% it will create a mistake. Okay, it is not good at that type of operation. Okay, so those types of aggregation related operations, or you want to list a list of items that you have in your database, and you don't want to miss out on anything, and your table has 1 million or 2 million records out there. Large language models cannot handle that, because their inherent nature is to do sampling. Okay, they always sample stuff. They will not take the whole thing. They will always sample. Even if you load your entire file into a large language model and say, hey, analyze this and tells, it does sampling. It does not read unless it's very small. With one chunk you get the whole information, then it doesn't matter. I'm talking about large files. Okay, it does sampling, so it will not go through the entire file. If you're meticulous enough, you will start noticing it. Now, if you are trying to analyze a file which you don't have any expertise or idea about, and you completely rely on large language models to tell you what the file is all about, that means you're taking a shortcut. Then you will not find out the mistakes that it is doing. You will tend to believe that whatever it's saying is right, and you will take it. And this is a trap. So you need to be aware of these things. Okay. So that means you can't make these mistakes when it comes to data that you are taking from something. Let's say you want to know so average of something, or what is the the highest of something, right, or lowest of something, or something like that. These are business related questions. You need to be accurate. You cannot be wrong about it. So that means you need a combination of these two. So that is why when we design these solutions, we always have a combination of these two, and we know what to put where. Okay. Now, typically these types of things you won't hear from YouTube channels. Okay. We do it, and that's why we are sharing it with you. So the point is that so this is the limitation of RAG. So the limitation of LLM is carried on to RAG. RAG also does sampling, and that means you cannot ask questions, or if you don't rely on RAG to answer questions which are like aggregation related questions, or which we have to be meticulous about it and you have to be accurate and all that, right? No, that's not the right solution. So the trick is how to make them to work together. So, okay, so this is the ingestion pipeline. Then the query pipeline starts. Once the ingestion is there, vector database there, then the query pipeline, the users start asking questions. The question is also embedded in terms of the embeddings so that the dimensions have to match. Okay, so the vector database dimensions, the dimensions, and the large language dimensions have to match. Otherwise, you will not get the right answer. So the dimension matching is absolutely important. And then the semantic search comes into picture, which is the nearest neighbors, which is what RAG is great about. The searched information. So basically, when you ask a query, the search is done on the vector database. The related chunks based on the semantic search is given to you, and only that context, which we call the good context, is passed on to the large language models along with the question, and the large language model has no other option other than to work with your data that you have given. Okay. Well, that's what we assume, but still that there can be breaches and things like that. But then we try to limit the hallucination problem that we have with the large language models, and you get an answer. So this is the whole pipeline. Okay, this is the central piece. Rest of the content here will go into the details of how do you design each of the components. And the rest of the things goes into how do you set up the Supabase content, because this will keep on going. Okay, so this is a big slide, and it also talks about how to build a RAG pipeline in N8N, because I'm being conscious about the time I'm taking, because we are already about 45 minutes into this, and this is halfway through. So I really would like to take a pause. If you guys have any questions, I will answer if anything needs to be handled. So typically what happens is when we give these courses, we also give content that people can download and work through. So this is about how to work through those content. Okay, so there are PDF documents, Excel spreadsheets, CSV files. How do you do processing? How do you do chunking? How do you insert this into a Supabase? How do you set up Supabase, which you saw? How vector databases are created? Which options to select? Okay. How do you handle metadata, which is critical? As I said that when you're processing documents, you also collect metadata. Okay, you don't blindly create vector databases. You collect documents and metadata. What metadata you will collect about your files that you're loading, file IDs, file title, file URL, and potentially you might want to collect what type of file it is and things like that. Metadata about the file, whether it is a doc file, PDF file, JPEG file, it could be an image, any other file, right? MP3 file, MP4 file, whatever file, right? So you want to collect all this information. You might also want to collect additional information if you want. That's a different topic. Okay, so but idea is collect metadata and store this metadata into a table, which we call as documents table. So this is our style of doing things. Okay, so when you create a documents table, then you have in Supabase or PostgreSQL, you create a function called a match function. This needs to be determined. How to build all these things? We potentially can share the code base with you guys, and you can work through this. that is the super base version. This is the local version of PG vector. Okay, suppose if you don't want to have a super base version, you want a local version, which means the PostgreSQL is inside, you are handling yourself, which maybe you have a Docker container and put your PostgreSQL running from there. How do you do it? Okay, how do you create local file triggers, which means that it's not Google. So basically, this is the local version of the cloud version. Okay, so it covers all those things. So I'll not get there, go deep into it. Okay, so in conclusion, because this is like the halfway mark, I need to go to the agentic structure. Halfway mark mein kya hai? So RAG, I mentioned, is a knowledge extension system to large language models. It deals with vector databases because it deals with vectors and embeddings. Embedding models have its own dimension space, and you have to match the dimensions of your embedding models with the dimension of your large language model, which is going to interact with this. If there is a mismatch, you're going to get garbage. Okay. So then RAG workflows we talked about, it has two different workflows. One is the ingestion workflow and the query workflow. And then in the ingestion workflow, we talked about chunking. Chunking has various different types of chunking, fixed versus overlapped versions also is there. And contextual chunking is also there. Many sophisticated things are there within chunking itself. Then apart from that, we talked about variations of hosting the RAG database. One is the Superbase version, Postgres version, which is the local version, which you can build. Okay. Yeah, from a large language model wise, OpenAI, Claude, and all those, the cloud version, you can have a local version running. If you have a GPU based system, you can have Olama and other type of large language models, which they give it to you, which you can run it on your own. So you can save on those things. So there are lots of models that are out there, both the local and cloud-based. What is happening is people are going more towards cloud-based models than the local ones, because like really you cannot compete with the pace with which the cloud-based models are improving. Especially a lot of small models have come, which are potentially able to give the performance of a costlier model. Like when I say costlier model, my benchmark is Claude. But there are a lot of small models like Qwen 3.7, I think, Kimi 2.7 and things like that, right? So these are much smaller models. They are quite capable, but they are not thinking models. So you would want to have a mix of these things. So these are kind of details that are out there, where how do you create efficiency even within this ecosystem. I will stop here. I will, if anybody has any questions, if any topics you want me to go deeper, you let me know. Did this section make sense? Okay. Is any topic here that you guys want me to go into? Anything you want me to double click and go? Otherwise, I will go into agentic RAG. Okay. So I'm getting only yes as an answer. So I guess everybody are good with it. Okay. Let's talk about, okay. So before I go further, this is all theory, right? Isme maza nahi aayega. So point is, everything, there is a code base here, okay? I kind of like, if you have access to this, you will have, I will show you, I'll try to show you something before I start the next topic, okay? So I may not be able to run it though, because I don't have the time for that. I can show you what it looks like. Okay, this is innate. Am I sharing my screen? Okay, this is our company's N8N instance. And this is my personal one. So I have various different things. So I've created this rack folder for you guys. I've already downloaded the content. Okay, so let me just show you the content that is out there. Okay, I can stop sharing again. Okay, 1 second, guys. I want to show you. Okay, if I am too fast, okay, I'm sorry, guys, because there's so much things are there now, little time. So so generally what happens is the code that you saw when you download it, you get a zip file. This is for topic 4.1, and it already has this is for N8N, okay, and it already has these sample files and things that you can run, and the database that you want to create in either in a PostgreSQL or in a Superbase, whichever. The SQLs are there. It will create all the tables and the matching functions and all those things. The files that you would use to test all of them, how to build that, that is all there. The workflows are there. The README is there. README will tell you exactly what to do with it. Okay, so it is already laid out for people who have access to this. Okay, so I'll show you. If you open the README, it will tell you exactly what you need to do, what are the instruction sets and things like that. That's why I'm not bothering explaining, showing you too many things, because that content is already there. I'll just open these workflows and show you what it looks like. Okay, so that will give you a perspective in N8N. So I want N8N. That's my N8N. Did I close it? Okay. So this is our N8N instance. You can go here. So I'll create a workflow, and I'll just import from the file that I have. It should open somewhere here, and it is in downloads. 4.1. Okay, so you have the ingestion workflow, and you also have the agent workflow. So let me import the injection workflow. Okay, so the injection pipeline is already there. Everything is already set up for you in terms of how N8N works through. Okay, all you need to do is pull those files, set those fields, and just run this. So it will work, and it will, essentially the pipeline steps are already there. It's what it will do is it will ingest all these files for us. Okay, once you do this ingestion, then you can go to the next workflow, import the next one. Ingestion we did, right? This is the agent chat. This is the chat version. So once you have ingested it, all the Postgres connections and everything, it will know it. You will have to set this up. Instruction to what to set and everything, it's already pre-built. Some of them are already pre-built. But whatever you need to do to set this up and things like that is already there in the instruction sets. Then you can just basically chat with your agent. So this is like a chat trigger. So you can chat. I haven't run any of these things, so it won't work. But once you set this up, it will work. So this is a typical RAG solution built on a visual flow tool like N8N. The Python version is also there, right? And okay, so this is section, yeah, this is 4.1. 4.2 is about 4.2 is about agentic RAG. As I said, like I have videos. If you like to watch videos, you can watch, you can play. I'll work with slides because I'm talking. Okay. Do you guys need a break or can we start? We have about an hour.
You can start, sir.
Okay, fine. I mean, if somebody needs a 5-minute break or 10-minute break, we can give. It's okay. It's okay, fine. We'll go. Okay, so agentic. So this is the advanced version of RAG. We'll call it advanced version, but just a bit more complicated version of RAG. That's about it. But it does deal with AI agents. Okay. So I remember I mentioned RAG, if your solution that you build is just another tool to an AI agent. Now we will talk about a little bit about AI agents. So there are two limitations about RAG. We already mentioned it about naive RAG. Structured data doesn't do well. Next problem is full document. When you load a full document, basically when you have to interact with any document, right? No matter what document it is, you don't need the entire document in memory to be able to answer query that you're asking. You might ask a query that might be in, let's say, it's a book. Let's just take a book. Would you ask a query that requires the entire book? No, right? When you have a question to ask and when you want an answer, you don't ask a question that covers the entire book. If you want to, then even if you do ask that question, then you're limited to only the index portion of the book, basically. What you end up asking is that very pointed questions and small sections of or different sections of the book might have the answer to your query. And you need only those things loaded in context, not the entire book, right? So this needs to be kept in mind, okay, when we build these systems. So how agentic RAG works? So agentic RAG means you will have multiple retrieval strategies instead of a single lookup path, basically, right? So you have one database. This is all my documents. You fetch only from this. That is not the strategy. You'll have multiple retrieval strategies because the data might be spread out across multiple places. And this is typically the case where we end up using agentic RAG solutions or agentic, yeah, we call it agentic RAG, but essentially it is agents. RAG is just one piece of it. Then there are other pieces that are there available for the agent to work with. Okay, so there is, even though I say that, even RAG, there are multiple types of RAGs also. We will get there. I mean, if time permits, we'll get there. So, okay. So the first example we creating documents table, and the document table had all the documents in rows, and it had a matching documents function, which will basically work with the index that is there, and it will find the matching documents that are based on your questions that you're asking, and based on that, it will answer your queries. But there are additional two schemas that can be added to the structure. One is called the document metadata. The other one is called the document rows. Where are these two things useful? Suppose if you have an Excel file, okay? Excel file typically comes under the files category, where the way you deal with a document, Word doc file or a PDF file, people tend to deal with Excel file also, but Excel files generally have structured data, right? It has tables, columns, etc. If you think about it, it's actually a table. Now, what is the best way to store an Excel file? Okay. Now, when you create an Excel file, what will be the type of questions you will ask from an Excel file? Will it be the same type of questions you will ask from a doc file or a PDF file? Will PDF files or doc files you have might also have, okay, this is like a slightly advanced version, okay? I don't want to confuse you guys, but they also might contain tables. Now, if you want to extract those tables separately and manage it separately, that is also possible, but that's slightly advanced version. But let's keep it simple. What are the type of queries you will ask for from an Excel file? It will be different from what are the type of queries you will ask from a Word document and a PDF file, point blank, right? So typically the questions you will ask is, which is related to numbers, which is related to aggregations, which is related to, exact lookups of something, etc. That is not the typical way that you will deal with docs files or PDF files when you are dealing with text, okay, or for that matter, images. So how do you need to store the Excel files? Now, naturally, it has to be different. It has to be stored in a slightly different manner than how you're storing your docs files. So how do you store it? All right, so that is the question. So there are two extra tables that we create. One is called the document metadata table, and the other one is called the document rows table. So document rows table. So basically, first of all, we differentiate between the files itself. If it's a docs file, my PDF file, and XLS file, everything will be dealt differently. So there will be multiple pipelines running. Okay. In the ingestion process itself, that means you are going to collect multiple types of metadata for different types of files. Docs files, you will collect different types of metadata, and for XLS files, you will collect a different type of metadata. Bottom line, this is what you need to understand. Now, once you create this, then you can ask one of the simplest problems you would face when you create a naive RAG system is that even if you have a 10,000, as I said, 10,000 documents are there. If you want to list out this 10,000 documents, the RAG system will not be able to do it. It's the most obvious question, right? So when you load a million files, you want to know what are the files that you have loaded. You want the list of files there, right? This doesn't necessarily it's not available with the RAG, because how RAG stores is it converts everything into embedding, and it creates associations with these embeddings, and then that is all good from a association point of view. But you want the list of documents, then it will struggle. It will not give you a full list. That means you will have to create separate approach to create a list of documents. Now, since we have this metadata tables, we'll be able to do this. Okay, so these metadata tables that we are talking about, right? This document metadata, the document rows, these will actually supply the necessary data for answering some of these questions. So if you ask to a list document, it will fire it differently. It will not go to the vector database. Okay, it will go to the metadata table, and it will fetch all the list of documents that are already recorded in the metadata. It will answer, and this decision is made by the agent, and that's why it is called the agentic RAG. Okay, and that is why we say that it is multi-retrieval strategy. Okay, so then you might ask a question about getting full file content. Or you might, and RAG also suffers from this. Once it is chunks, it has a very hard time putting all of them together. Okay. Then other thing is, you might end up creating different The data will be different naturally. Language form way. How will the agent know which particular Excel file to fetch and what type of data it needs to fetch from it? Right? It has, so you need to be able to do that association also. That is also being done in the RAG system. That means query on the fly, a query will be written. When your natural language may you are asking questions, the agent will write a query which is appropriate to answer the question that you're asking for. Okay, and it has a bunch of tables that it has to choose from. All of them will come from the in a combination of document metadata, documents, and the document rows tables. Mainly documents and document rows tables will answer that question. Now, this type of modeling, this is data model, okay, which I am telling you is a data model. Typically, you won't find this outside. This is again, it's our method that we are sharing. Now, it solves a lot of problems, by the way, because we kind of solved all these things. Now, recognizing why non-deterministic retrieval, letting agents choose this approach and produce more accurate answers. So basically, the point is the agent recognizes deterministic versus non-deterministic retrieval methods, and it chooses the right approach to answer the question. And that's why you get the most accurate questions, spending less amount of money, okay, or minimal amount of money that to achieve a job. So limitation of naive RAG, I already mentioned all these things to a large extent. Structured data and math related questions, if you ask, LLMs in general will struggle. If they get it right, that means there are a lot of loading happening behind the scenes, or processing happens after the answer has come. So they also do this pre-processing before the answer to you. Okay, so they look for these type of things. Okay, so this is the example that I was talking about. Imagine you have a table of 2000 rows of revenue data. It can be more typically. LLMs are bad at math. Chunking splits the tables. So if you remember the chunking method, if you apply two tables, you will have, like, say 50 records in one chunk and 50 other records in one chunk, and you're asking for a total. It might retrieve the chunk or it might not retrieve the chunk. Okay, and then upar say, if you want a sorted list, then it is gone. Okay, you cannot do sorting. So these are limitations. Okay. Lost context from chunking, right? I mentioned it, it is coming here. So you understand, right? So naive RAG is like reading a book by looking at random paragraphs. You won't have any continuity. It is by nature, it is random. And then you will miss all these connections, how this is related to that and all these things. So agentic RAG lets an agent decide whether to read paragraphs, read the whole book, or run a calculation on the data instead, which means what type of retrieval method is required for answering a question. So this is like the advanced version. As I said, it basically, why it is advanced, it removes many of the negatives that we find in the naive RAG system. And so typically when an agentic RAG is attempting, so this is an example of how it behaves. And let's say if you want an average of a new customer, so these examples are there in the files. So similarly, the files that I've shared, 4.0 also has a set of files that you can load, you can run, and you can look at the queries and you can see how it behaves. And whatever you're seeing here, you will see there. Then you can put your own data and you can experiment. Okay? So then the point is, agentic RAG attempts. So let's say, I think this 98, it is coming from a pure RAG system. But the agentic RAG, when it appears, it writes this particular query that you see on the screen. It selects the average of new customers, and it gives you out specifically the number is 101.25. This is the exact answer. You can check in the given examples that are said. So this is just a verification. Now, whatever I am saying now, you can test it and see. You don't have to believe me, but this is how it works. Basically, what happens is you have a naive RAG, you have a user question, vector search, partial chunks. You typically get a wrong answer. By chance, you might get a right answer, but then most likely you will get a wrong answer. But in agentic RAG, all the time you will get the right answer. Okay, because it's going to when you ask this type of question, it's going to know that it's not going to use vector search, it's not going to do full document search, it is going to do a SQL query. It knows that, it chooses that, and gets the answer. This is essentially pretty much the whole concept. So definition of agentic RAG is straightforward. You give the agent the ability to explore your knowledge base in different ways, depending on the question you're asking. Again, right? The user asks those questions. So again, more of the same comparisons. For those of you who wants to go through this again and again, you can do that. The same concepts are still applied. So the RAG concepts of semantic search is still applied here. Full document retrieval, that's why you have the list of documents and the get the file contents type functions that are written on the databases. So similarly, match documents function you wrote, similarly, you will write some extra functions for this to get these things. And then the query documents rows. So this is large language model writes the query, by the way. Okay. Depending on the questions you're asking, the same of similar things. Okay. So when you set up a database, you are looking to set up the documents table, which you probably did in the previous version. If you run it, I think you will do it in this version also, either way. But in this version, you will create these additional tables. One is the document metadata table, this is meant to store high-level metadata information. Why you need this high-level metadata information? As I said, you will be loading docs files, XLS files, PDF files, etc. You need to know the metadata to know that if it's an XLS file, then you will have to have a different approach to retrieve out of it, and you need to go to a different section to retrieve that information. This is for this is the type of metadata that is collected. Metadata means that's ID, title, created, URL, and the schema. Schema is the columns in your spreadsheet file. Okay, so that means you can have any number of Excel files in this system. It's already normalized. Okay, so the schema column is the clever part. Regular document for regular documents which are not having any schema, that stays null. Typically when you have so you might be collecting any kind of data. Okay, so this is an example of having a meeting and minutes of the meeting is collected and you're storing that as a document for your records, if that's the case, and you want to use RAG for that. So typically columns look like this, months typically like this, these structures are there. That structure that you saw there, that the actual rows from the spreadsheet. So one is to store the schema. So you're storing only the header column. Rest of the data, right, is stored in the documents rows, and that association is there with the metadata. So that means you can have n number of rows in an Excel file. All those rows will also getting captured, and the metadata is there in the metadata table. So that's the leverage that we are having, and all the row data is stored as a JSON-B object, which is JSON binary. It's one big key value pair store. Extremely efficient. This type of storage can be extended to storing images also. That's the advantage of this. Okay, so you okay, here's a typical thing. So this is I talk about JSON-B, it is coming right after this. So basically JSON-B is powerful, and it just talks about all the different things that you can do with it. Okay, so we have an updated pipeline. So the same 4.1 pipeline you have, what you saw, we will see the 4.2 version of it, and you will see the difference between them, where the metadata files are coming and how it is getting stored and all that type of stuff. Okay, so I just want to make sure that I cover everything. Extra steps for spreadsheet files, insert table rows. This is done through a loop through the spreadsheet, and so this is all in the workflow. And the update schema to document metadata that I'll show it to you in the drive in the workflow. Okay, so this is I think we started at 5. Oh, we have a stop at 5, right? I thought it's 5:30.
Yes, sir, but you can complete your topic.
Okay.
It's 5 o'clock.
Okay. So I'll try to stick to the time. Okay. So building tools, listing documents. So these are the type of queries that you will get written. So the point is, see, there's no point in me showing all these things. This information is already there. I will rather show you the workflows and how it works, because you can see all these. I just want to show how the structures are created. These are like things that you can see when you get into the depths of things. All this information is there. It also tells you how to verify how it works. It tells you what to watch for, what you will get as an answer. It sort of spells it out for you. The option of having Superbase and PostgreSQL is also coming after this. Okay. So key things that you need to note is the limitation of naive RAG. It fails with structured data, point blank. Agentic RAG gives multiple retrieval options that is practically useful. We added 2 more tables, which is one for metadata, document metadata, and document rows. This is a prototype structure. In real world, you could end up creating more complicated structures, but the requirement has to drive it. 3 powerful tools. So function definitions. One is list documents and get full contents or query a document. So these are functions that we will be defining it, and also the so these are the tools that we will define for the agentic RAG, but the description of the tool is also important, which is the most important thing most people miss. So when we write a tool, or you think of it as like a function, right? It is a function, but that function is written for human beings typically. But for agentic systems to understand by reading that function, you will have to give a good description for it. Okay. So that also is there, how to write those descriptions so that the agent at runtime, it is not struggling for choosing the right tool. Okay, so that also matters. Everything matters. Seconds, as I said, seconds matter, milliseconds matter. So how do you achieve it? By these small nuances that I'm mentioning about. That's how you achieve. So I will go back to so in 4.2 also you have similar structures. We will see these 2 workflows. Okay. I'm sorry, I'm not giving enough space for questions. Okay. I should have. Okay, so this is the ingestion flow. Okay, way more complicated than the basic one, but it is not. I will explain to you. Okay, basically it looks for file types, and depending on the file types, it does different processing. And once it does the processing, it aggregates that information together. Once it aggregates, so basically depending on whether it is a document, it starts loading into different sections. So this is the metadata collection part, the actual document insertion part. Okay, so it looks complicated, but then the only thing is that I've added this portion and this metadata collection portion. Rest of the things are the same. Okay, between those 2 things. Okay, so the other piece, one more, and one. Yeah, agentic response, right? Now you see the magic now. Okay, so the agent has an ability to connect to multiple different functions. So I will have to zoom in for you. Because so this part you're familiar with, agent, this is chat memory, this is Postgres store, this is where we stopped in the last part. These three functions are added. One is for get full document, write a query, and this is about list documents. So if you look at the content of what is written here, this is the query that is written. So it's just a typical SQL query. Okay, so it is essentially written. It gets the contents from documents, and it sort of gives you that. I think I can go to the. Okay, the interesting part will be how it writes. So, as I said, the important thing is the description part, right? Let me see if I can expand this. Right. So this is the description part, which essentially spells out to the agent how it needs to, deal when it has to write a query. So what are the different things that it needs to look for, and where it comes from, and etc. This is optimized for the data that is already loaded. So this is, we already know these things, right? Now these can be generalized also for situations where you don't know how many files you have and all that, right? So this can be generalized for this particular use case. It is written like that. Now this is for listing files. This is a typical straightforward query on documents listing all the files. So that's why we have the documents folder. Okay, so typically when you run these things, you can see this in the SQL in your Postgres database or your SQL database. You will see records showing as you process these things. Open those two screens and then run these things. You will see all these things happening live in front of you. So I'll stop here, and for the content and things, whoever is in touch with me, I will share it, and you can pass it on to the rest of the audience. I will just stop here. If any questions, we are on time, but I can spend some more time for questions. Was this useful? What do you guys? Okay, so for the courses, if you want, so you can actually go to the site called AIFCC. Okay. So you can go to this AIFCC. You can see the plans. The first one is free. You can just go through that, and then you can buy them essentially. So it's the fundamentals is about 7,000, and then the builder and the architect level. So basically, whatever I showed you, is till this portion, and like not even this. 2 sections in one of the modules is what I showed you. There are plenty more out there. So this is coming from not theory, guys. This is practical. We are building these systems and we are delivering solutions to companies. So none of these things go very, very intense. Okay, so it will go deeper. Our intention is that anybody who wants to build any prototype or anything, like if you are a college student or anybody, if you want to get a job, you have to show people what you can do, right? And unless you know how to actually build something and publish something and put them in as a portfolio, you'll not be able to do it. From builder onwards, we teach you how to deploy it in cloud. So cds.com, and you can enroll. You can see. And we do 2 workshops for people who enroll in fundamentals, workshops like this, and answer questions. And if you have any trouble, problem, anything like that, we try to solve and all that. Yeah. So those of you who are serious about taking AI agents and build a career out of it, these are things. Builder is there that takes you all the way to document processing or even Claude skills. And then after that, it becomes very, very serious. It's an architect level course where you're actually building some serious stuff from this point onwards. This in itself is good. This fundamentals and builders is more than enough. Somebody had any questions? Yes, somebody raised a hand. Okay. Hope you guys had a good time. Okay. Hope it was.
Thank you, sir.
Priyanka, yeah.
Yeah, thank you, sir. Today's session helped us to understand the importance of RAG in enhancing AI responses with reliable document-based information and how vector database and embedding enable efficient semantic search. Also, the complete RAG flow from document processing to generating intelligent responses through LLMs, practical implementation of RAG pipeline using N8N, Google Drive and Supabase. Also, significance of chunking metadata management and knowledge-based configuration for building effective AI-powered systems. So your ability to explain this advanced concept in a simple, practical, and engaging manner has greatly enriched our understanding and inspired us to explore AI-driven teaching and learning solutions. Thank you, sir.
Thank you so much, Priyanka, and thanks everyone for the opportunity to interact with you guys. And yeah, we'll be in touch. Thank you, guys.
Before we conclude, I would like to propose a vote of thanks. I take this opportunity to express my heartfelt gratitude to the management of WIT, respected Principal Dr. S.R. Genge sir, the organizing committee members, our esteemed resource persons, and all the participants for their active involvement and support in making today's session success. So with this, I formally declare that day 2 of our faculty development program comes to an end. Let's meet again tomorrow sharp at 2 p.m. for yet another insightful session. Thank you once again. Have a pleasant evening. Thank you, sir. Attendance link will be shared in WhatsApp group. Okay, and also it is shared in chat box. Also. Thank you.
Thank you, sir.